Hi everyone, I'm Eldin Jacob from Samsung Semiconductors India Research Bangalore. I am here to present on topic a hardware and software integrated power optimization approach with power aware simulations at SOC. New age integration. New age chips come with multiple power domains and different power rails. The different power rails are connected to the different voltage domains. That is, some might be connected to 3.3 volt, some might be connected to zero point 0.6 volt, etc. So this helps in the reduction of power consumption of the chip. So the some of the modules that are working under the higher voltages will consume a lot of power when compared to the lower voltage rails. So such differentiations are possible only if the chip itself is divided into different power domains and the individual power rails are present. So such a simulation is possible only in power aware simulations. Here we'll be discussing on the power aware test bench development. First, as in every other test bench development, this will be the power aware test scenario development. Next, we have these UPFs, that is Unified Power Files, which contains the different power domains, power rails, and clock domain information. So these are integrated along with the design and then given for compilation so that the complete design, once it is taken up for simulation, it has all the voltage rails and those can be connected to the different power supply. So the power supply is given by another module known as PMIC. So the PMIC is not a part of the simulation or the chip, and it is a part of the system that the particular chip is going to be part of. So this has to be a part of the TB or the test bench. So the test bench development includes a PMIC behavioral model development, which has the startup process specified as a part of the behavioral model. Next, we have the checker development. We have the different rules that are mentioned in the mentioned for power aware simulation. That is the retention rule, isolation rule, etc. So we have the individual checkers for each of them. If the checker fails, we go back and visit the UPFs that are generated. Now, regarding the particular design that we are considering, we have almost 14 blocks. We have 79 clock domains, 75 power domains, and also 37 power rails, which are connected to the different power sources. The different approaches for reduction in power is mentioned here as variable voltage level reduction, switchable power supplies, then clock shutoff, isolation cells for power shutoff, then voltage shifters for the different power domain connections and retention. And also the next process is power shutoff, which has the maximum power conservation and also maximum time for powering back on. Now we'll be considering the power controller architecture. We have a master slave architecture for the current design. The master sits in the always on domain and it controls the power domains that are directly connected to it and also the slave power domains. The slave controllers are controlled by the master controller and they have different power domains individually connected to the slave controllers. The different states of a slave power controller is given as the multiple stage uh, power states as shown in this figure. Whereas the Master power controller and the power transitions are similar, simple power transitions, and also similar to the second one, that is true. We have multiple intermediate stages for the power saving technique, power down process. First is the LPR, which is like a low power state that some of the IPs have their own low power states. That comes under this particular state, where if there is no data transmission in a particular state for a particular duration, it goes to the LPR state. Then we have the clock shut off, isolation state, then we have the power shut off state, and then we have the reset stage. Next, we will be discussing about the power estimation process. Power estimation process comes as a requirement from the design side. They have a power requirement for a particular module. So the sequence will be initially given by the hardware team, where they will say the particular state in which the different power domains are, depending on the state values. So we have the different power estimation sequences like clock gating, clock gearing, and power gating. Then a combination of these techniques will be used for generating a particular stage scenario based FSDB and given for power estimation. Once the power estimation values does not match, then this will go back as an iterative process. Next, we have this power estimation is done as part of RTL simulation, power aware simulation, GLS simulation, as well as power aware GLS simulations. Now we'll be discussing about the results. The power reduction processes can be done either by hardware process or software approach. Hardware approach in individually has different power states that has to be programmed as part of the RTL itself, and this has different wires that are newly generated to indicate the transition towards and also wake up from the power state. Next is software based approach. Software based approach is also supported by the current power controller, and this takes approximately 200 cycles, whereas the hardware approach takes only 40 cycles. This power wake up, but the power then we have the development of intermediate power states. The intermediate power states are developed in such a way that we do not tamper the power saving, and also the wake up time is also not affected by the particular scenario selected. Next, we have the power rail of scenario for power estimations. Once we are taking, earlier we used to take only the scenarios for power estimation under the RTL simulations. But nowadays, since we have a lot of power rails and individual power rails can be powered off for feature control, we are going ahead with the process of power rail of scenario based power estimation also. These are some of the power estimation scenarios or stages, and the power savings which are obtained from the particular simulations. As you can see, the clock gated and power gated stages will generate a total savings of 91% in the block level simulations. That is the maximum that we have obtained so far. And the real world values are similar to the ones that we have obtained. Thank you.